Good morning, dear children. In this video, we will learn to do examples of chapter number 11 of physics. The name of the chapter is Work and Energy. So, we will know how to solve numericals based on work and energy. So, let us start from example 11.1. The question is this: there is a force of 5 Newton. It is acting on an object, and as a result of the force, the object is displaced through 2 meters in the direction of the force, and you have to calculate work done. And you know that work done, the formula is force into displacement. Force is 5 newtons, displacement is 2 meters. So multiply 5 newton with 2 meters, and you will be getting answer 10 joules. So this is example 11.1. Now we have next example, example 11.2. There is a porter and he lifts a luggage of 15 kilogram from the ground and puts it on his head 1.5 meters above the ground, and you have to calculate the work done by him on the luggage. So the formula for work done, again it is force into displacement, but here the object is lifted above the ground. It means luggage is lifted above the ground. So in this case, the force will be equal to the weight of the luggage, and the weight of the luggage is given by the formula mg. As you can see, the formula for work done is force into displacement, but here force is equal to mg. Why mg? Because this much force is required to lift the luggage up, whose weight is given by this formula mg. So F will be mg and S is the displacement in the upward direction. So here we have mass 15 kilogram, g is 10 meter per second square as it is given in the question, and the height covered by the luggage will be 1.5 meters. So you have mgh basically. So multiply these three and you will be getting 225 Newton meters, or it is 225 joules. So this is example 11.2. Now we have example 11.3. So let's see where that example is. Yes, here it is. Example 11.3. The question is, there is an object of mass 15 kilogram and it is moving with a uniform velocity of 4 meter per second, and you have to calculate the kinetic energy possessed by the object. So here we have solution of this example. Here on the right hand side, just check. Mass of the object is 15 kilogram. Velocity of the object, it is 4 meter per second. And you know that the formula for kinetic energy is half mv square. So just put values and then solve it. You will be getting answer equal to 120 joules. Here we have mass 15 kilograms and velocity is, it is 4 meter per second. So as it is v square, so that is why this 4 meter per second is multiplied with 4 meter per second. It is written 2 times here. So you are getting answer equal to 120 joules. Now we have example 11.4. Question is, what is the work to be done to increase the velocity of a car from 30 kilometer per hour to 60 kilometer per hour if the mass of the car is 1500 kilogram? You know that if velocity of anything is increased, then some work has to be done. So you are to calculate that work done. So in this case, we will be calculating initial kinetic energy, we'll calculate final kinetic energy, then we'll find the difference, and this difference is equal to the work done. So see the solution here. Mass of the car is 1500 kilogram. Let's write initial velocity of car. It is 30 kilometer per hour. But as you know, this kilometer per hour is not SI units. So we are to change this kilometer per hour into SI units. So for that, 30 multiplied with 1000 meters divided by 3600 seconds. Or you can simply write here 30 into 5 by 18. So you will be getting initial velocity equal to 8.3 double 3 meter per second. Similarly, we'll find out the final velocity of the car. This is 60 kilometer per hour, and when you will convert it into meter per second, then this comes out to be equal to 16.67 meter per second. So let us calculate initial kinetic energy. The formula will be half mu square. So that we have calculated, it is 52,041.68 joules. So this is initial kinetic energy. Similarly, let us find out final kinetic energy of the car. This will be half mv square. So here, as you know, v is 16.67. So using that, we are getting this as the final kinetic energy. This is 2 lakh 8,416.68 joules. So how to find out the work done? For finding work done, you are to write change in kinetic energy, and change in kinetic energy will be final kinetic energy minus initial kinetic energy. So you subtract these two values and you will be getting answer. So this work done, that will be 1,56,375 joules. Other examples we'll be doing in the next video.